Good morning, class. We are about to do the Bernoulli equation experiment, or Bernoulli's. We're going to study Bernoulli, basically. Okay. Um, there's a lot of stuff that is associated with this. So the first thing that I want to make sure that I do is have all of my movies downloaded. Okay. And I want to make sure that I have my calculator downloaded. So again, this will not look like this. I will have other movies in here. So let's go ahead and go to paper. Give you guys a bit of theory. Okay, so this is how Bernoulli's equation looks. It's basically pressure plus rho. I think it's 1/2 rho v squared, 1, plus rho g y, 1. And basically this is going to be like an input. And then we have P2 plus 1/2 rho, well, that's the density of a fluid. Y sub 2 plus, no, not y sub 2. This is V sub 2. That's the second velocity. Plus rho times gravity, or the density of the fluid times gravity times y sub 2. Okay. I do want to confirm, pretty sure that it is it. Not to get super deep with it or anything, but basically we're going to have a scenario where we will have a container filled with fluid, and it's going to have an orifice where water can come out, or that fluid can come out. And so all of the stuff on the one side is going to refer to this. All of the stuff on the second on the second side is going to refer to this. So when we're talking about P1, we're talking about the atmospheric pressure being applied to this liquid. When we talk about V1, we're talking about the velocity of this liquid. Okay, so it's going to move down or up, or it might just be stationary. Okay, and I'll just put a 0 here for stationary. And then we're going to look at the height. So we're going to measure the height from some origin setting. And we can measure the height here. All right, so we know that we're going to have some y initial, and then we'll have some y final up here. But if y initial is just 0, then this is going to be our y sub 1. It's just going to equal to y final. Okay, so that is the left-hand side. But now you have the right-hand side. And the right-hand side, you're going to have y2 equaling to y initial. So in this case, it'll just be 0 since we're setting our origin there. And then we have a velocity coming out at this second position. And this velocity is what we're going to calculate. I'm just going to call that V sub 2. And we also have a pressure out here, okay? P sub 2. This is atmospheric pressure. So I can just say P ATM, that's atmospheric pressure. And this is also equal to P1 because the atmosphere is all around. So this is where we're going to go with this particular, well, this is the theory that's governing this kind of experiment. So what do we want to solve for? Again, we want to solve for the velocity